Hi, everyone. Jumping into graphing exponential functions today. I want you to look at the learning target real quick, and I want you to see a word that's very important. There's the word "or" there. I can graph an exponential function by either making a table of values or accurately using and understanding the shortcut. Okay. So I'm giving you two options on how to do these problems. All right. So before I do anything with exponential functions, let's look at an old thing that we used to do. How do we graph the following function? Y equals x squared minus 5. Notice this is not an exponential function. An exponential function has a variable as an exponent. That is not the case here. This is old. We did this back in first semester. We made a table of values and then plotted the points. And you remember how I told you, or maybe I had it, or if you had someone else, this one doesn't have any fractions. The x values I'm going to choose are -2, -1, 0, 1, and 2. And I just plugged those numbers in and got a y value out. So -2 squared is +4. 4 minus 5 is -1. -1 squared is 1. Minus 5 is -4. 0 squared is 0. Minus 5 is -5. 1 squared is 1. 1 minus 5 is -4. 2 squared is 4. 4 minus 5 is -1. So I got my table of values, and then I'm going to plot those on the graph. So -2, -1 is left 2, down 1. -1, -4 is left 1, down 4. 0, -5 is down -5. 1, right 1, down 4. Right 2, down 1. And there's your graph. Okay. I showed you that to show you that the table of values works. Okay. Now, how does it apply to today? We do the same thing with exponential functions, or we can do the same thing with exponential functions. I will show you a shortcut later in the notes, but you must understand why the shortcuts work before you use the shortcut. What I want you to understand is that a table of values is always going to work. It might take a little more time, but it will work. All right, so I'm going to jump in and do a table of values here. So no fractions, -2, -1, 0, 1, and 2. And actually, you're going to be doing that literally every time if you do a table of values, even with a fraction. And I'll show you why on the next one. Okay, and what we're doing is we're just taking each of those and putting it in for x. So 4 times 2 to the -2nd power. Now, this goes back to lesson 2 in this unit. A negative exponent means the base is not happy. So 4 is fine where it's at. 2 goes to the bottom and becomes 2 squared. So that's 4 over 4, which is 1. I'm going to do it again with -1. Okay. So 4 stays on top. 2 goes to the bottom, becomes 2 to the first, or just 2. 4 divided by 2 is 2. 0, if I put 0 in for x, keep in mind what a 0 exponent means. A 0 exponent means that 2 to the first power becomes 1, and I'm just left with 4. 4 times 1 is just 4. If I put 1 in, 2 to the first power is 2. 4 times 2 is 8. And then if I put 2 in, 2 squared is 4. 4 times 4 is 16. Now, I want you to notice the graph. It's not like our normal graphs. This is called an exponential graph. Notice how the y values are not negative. You're going to see that that's the case. You should have seen that that's the case with the last problem, the last lesson that we did with the growth and decay. You're not going to make a negative value. You're going to make a small value. So -2, 1. So -2, 1. -1, 2. So left 1 up 2. 0, 4. 1, 8. And 216 is off the graph. What I want you to see is this is curving upward. And that is your first experience with something that's not a line other than, well, I shouldn't say that. You did parabolas and stuff back in first semester, but you didn't see it with the function. Okay? This whole second semester is not linear, so not lines. This is the first curve that we're doing, and there it is. it's going to grow very quickly, which should make sense based on the growth and decay that we did. Our B value is 2, meaning it's growing, right? It's bigger than 1, it's growing, it's getting very big very quickly. Moving on to number 2. Do you see how 1/3 is my B value? That's less than 1. So this is going to be a decay. This one's going to fall very quickly. Now, this one gets a little trickier with how to plug it in. So 9 times 1/3 to the negative second. Now keep in mind how we did fractions with exponent rules. Each base needs a 1, or at least needs an exponent. So that's going to be 1 to the negative second, 3 to the negative second, which means those are not happy where they're at. 1 goes to the bottom, becomes 1 to the second. 3 goes to the top and becomes 3 to the second. 3 squared is 9. 1 squared is 1. So I've got 9 times 9 over 1, which is 81. Not going to fit on my graph. That's okay. All right, now we do the same thing with -1. I'm just going to erase all the exponents here until the end. So -1, I'm going to multiply each of those exponents by -1. So that's going to move 1 to the bottom and 3 to the top. And now I've got 9 times 3, which is 27. And 27 is the Y value. You can already see from -2 to -1, it's falling very quickly. 0, I'll put 0 in for your exponent. 0, 1/3 to the 0 power is going to be 1. That whole thing cancels out. 9 times 1 is 9. And that's the first one that actually fits on the graph. I'm going to go ahead and put it there. 1, if I put 1 in there, one to the first is 1. 3 to the first is 3. So it's just 9 times 1/3. So that's 9 times 1 is 9. 9 divided by 3 is 3. So 1, 3, 1, 3 fits in there. Last one is 2. If I put an exponent of 2, that's going to be 1 squared over 3 squared. Well, 1 squared is 1. 3 squared is 9. 9 times 1 is 9. Divided by 9 is 1. So 2, 1 is that last point there. Well, it's not the last point, but for our table it is. And this thing falls very quickly. Now, one thing I do want you to see, this does not ever go under the x-axis. So if I see somebody do something like this, where they drop it and it goes below, that's going to be an x and it's going to be wrong, okay? Because none of those numbers, the y values, are ever negative, okay? So these first 2 problems were plotting a table of values. Now I want to show you the shortcuts, all right? And to show you the shortcuts, I kind of need to show you keep the tables there. So I'm going to keep the tables. I'm going to erase all the graphs because I'm going to be scrolling here in a little bit. All right, scroll down. What did you notice about the A value on each of the previous 2 examples? So I'm going to go up here. I know those are kind of in the way, but I want you to see this. The A value for the first one was 4. The A value for the second one was 9. Okay. Did you see where those were at? A was 4, A was 9. Those were your y-intercepts. So if you come down here, shortcut number 1, the A value is the y-intercept on the graph. That's your first shortcut. If you look at the table, 0, 4, 0, 9, going back up here, the 0, when x is 0, it takes out b, doesn't it? And what's left is the a value. So every time when x is 0, y is the a value. Every single time. That's a shortcut that you can start with. Okay. Shortcut number 2 is the b value tells you what to multiply by as you move right. The b value is repeated multiplication. So it's telling you what to multiply by as you move right or as x gets bigger. Okay. as you move left, or x gets smaller, the b value tells you what to divide by. So it's kind of like, yeah, the opposite of multiplication. Now I kept the tables here because I wanted to show you what happens. I'm going to scroll back up here. So my b value is 2. Look what happens. As x goes up, I multiply by 2, multiply by 2. As I go smaller, I divide by 2. I divide by 2. On the other one, the b value is 1/3. That means 9 times 1/3. Well, that's the same. Timesing by 1/3 is the same as dividing by 3. Dividing by 3. And dividing by 1/3 is the same as multiplying by 3. It's a little bit tricky there. I can explain that more later, but I want you to see that. All right. That was the explanation of the shortcuts. Now let's apply them to the last two. I'll show you how quick they can be. Again, if you don't understand these, you can always plot the points with a table of values. The a value, I'm going to go ahead and make a table of values just to show you how quickly you can do this. A value is 3, so I'm going to put 3 right here. The b value is 3, so that means I'm multiplying by 3 as I move up, or actually as I go down the table. So 3 times 3, 9. 9 times 3, 27. And then as I go the other way, I divide by 3. I do the opposite. So I multiplied by 3 as I went down. As I go up, I'm going to divide by 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. Okay. So now I'm going to plot those 0, 3, 1, 9, 2, 27 doesn't fit. Negative 1, 1, and negative 2, 1/3 is like 1/3 of the way up. Again, not going to be negative, right? It's just going to get very small. It's going to get close to the x-axis. It's not going to go below it, though. This makes sense. It's growing because b was greater than 1. In this one, b is less than 1, so it's going to be decaying. Let's make our table. Negative 2, negative 1, 0, 1, and 2. 0 is where I always start. It's the a value, so that's 2. As I move down the chart, I'm going to multiply by 1/2. Multiplying by 1/2 is the same as dividing by 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. I go the opposite way, and I do the opposite operation. So dividing by 2 as I went down, I'm going to multiply by 2 as I go up. 2 times 2 is 4. 4 times 2 is 8. Okay. Now, if you start from the very top and just go down, 8 divided by 2, 4 divided by 2, 2 divided by 1, 2 divided by 2, 1 divided by 2, you see that it's consistently dividing by 2, which is what the b value shows. So negative 2, 8, negative 1, 4, 0, 2, 1, 1, and 2/2. And there's your decay function. Again, if you didn't understand the shortcuts, it's okay. You can make a table of values and go through it that way. I am going to try to convince you in class of using the shortcut. It's much quicker. It makes you understand what's going on better. But if you don't ever understand it, it's okay to just plug in the values. That's it. Moving on to the last lesson in the next video.